having me. The story behind the blind invite is that right about that time when Alex messaged me, I was actually at NGConf, and I was just getting ready for my talk, and I was freaking out both about the talk that was upcoming, as well as the fact that I was going to speak for the very first time in Romania, which is my country, right? So I'm really, really, really happy and thankful for being here, and I look forward to speaking with all of you throughout these 2 days. And hopefully, I'll get to meet a lot of you. And today we're going to focus on serverless. We're going to learn about serverless together. And we're going to start with time. Time is absolutely crucial when we're building products. Serverless is here to help us spend time on things that are important instead of stuff that seems shiny but isn't essential. How many times as developers did we get really excited about technology that was very new and we weren't really sure that it was solving our problem, but it sounded really cool? That happens all the time, right? But it's not always great for our products, and it's not always great for our teams and the way we work together. And serverless will help us bring that excitement into our team, work with new technologies, but at the same time, make sure that we are building the products that we have to. And when we incorporate serverless into our applications, we no longer need to worry about configuring servers. That will be handled by the platform provider, as well as auto-scaling our applications, so making sure that we meet the workload that our user is creating for us. And finally, probably one of the most important things about serverless is that you only pay for the resources that you're using. And we're going to look at a story that shows us how impactful abstractions of servers is. So Anthony Casalena, who is the founder of Squarespace, wants to empower every single person out there to build their own website without ever having to code. So that's like stealing our jobs in a way, maybe. In his own words, Squarespace is working on solving the problem of self-expression. But before he actually got to tackle that very important problem, he needed $30,000. And that's how much money he had to spend on 2 servers, buying 2 servers, back in 2000, in order to release his very first version of Squarespace, so make it available for everyone out there that wanted to build their website. And after his initial investment, he went on to hosting his servers in his dorm room. He was a student back then. Can you imagine that? Being a student in a dorm room and having to host 2 ginormous servers. And the actual logistics of that. Obviously, that didn't work out very well. And he ended up moving those servers into an actual data center, so renting space there. And that added to the cost of his product and his business. And not very long after that, he also experienced his very first outage. And with that, he also experienced the panic of losing his entire data, his user data, which was the equivalent of losing his business. That's pretty scary, right? You're just starting, you're a student, you've invested all this money, and everything is gone. Not fun at all. Eventually, he also had to replace those servers because they go bad. So $30,000, that was the initial investment that Anthony had to make in order to build a product for his users. And probably that was the case for a lot of the startup founders around that time. And this is what virtualization, or infrastructure as a service, helped move forward with. We basically didn't have to buy hardware anymore. We don't have to worry about hardware getting broken. Now we can start building our products without having to make that upfront commitment, financial commitment. And serverless is the latest step on the path of taking away the burden of infrastructure and has a similar impact on getting us started with building our products. Only now, it will free us up from having to manage those servers and having to configure them and having to patch them with security updates and install web servers and operating systems. So all of that work, all of that operational work, we no longer have to do it when we start building serverless applications. And that means that it frees time for us, which is money as well. This is a pen by Sarah Drasner that I absolutely love and takes us through the journey of moving from infrastructure as a service to functions as a service. And much like high-level programming languages are an abstraction of machine code, serverless is an abstraction of cloud infrastructure. So with low-level programming languages, we have to know how to manage memory, how to allocate it and deallocate it. We have to kind of provision that memory. And with serverless, we don't have to do that anymore. With traditional applications, whenever we're working with traditionally hosted applications, we have to kind of answer those questions. How many users do I expect to be on my websites? How much infrastructure did I provision for that? And how much would I need if there's a spike in my traffic? How do I configure that? How do I make it auto-scale? We have to answer all of those questions. And just like high-level programming languages took away that configuration from us, and we can just focus on writing code and building applications faster, just like that, serverless is helping us build our applications faster. It enables us to focus on the code that's relevant to our product without having to worry about babysitting servers, just like Sarah would say, and said many times. Serverless gives us the ability to focus on the important things right from the beginning. And in our case, important means solving problems. We're all passionate about that, right? That's the one thing that programmers like to do, solve problems. The next thing that we have to worry about, so we're starting building this application, and the first thing we worry about is, well, what kind of servers do I need? What's my web server? And all that infrastructure questions. And then as our application becomes more and more popular, we start thinking about scale. We start thinking about what happens when we have more and more users. And every 5 years, millions of Australians have to fill in a census survey. And in 2016, the Australian government decided to run that survey online instead of having people go on site. And they spent $9 million and probably a lot of time building an online survey form. And they told everyone to go home and fill in the survey. And that's exactly what happened. Everyone went home at the exact same time after work, and they started filling the survey. The next thing that happened, the website has crashed, and census fail is trending on social media. That's never good news, right? So the government managed to gather very little data about their people, and they ended up spending other tens of millions of dollars to fix those issues and also fix the marketing disaster that happened. In a completely different environment, the weekend after the failure, 2 students at a hackathon, they were trying to figure out what kind of problem do they want to solve, and they ended up replicating the census website. So they downloaded all the static assets that they could find, and then they implemented their backend using serverless. So 2 students, 72 hours. After the 3 days, they also ran load tests. And it turns out that they were able to serve even more requests than the initial predicted load for the census website, for less than $200. So $9 million and $200 without census fail. With serverless, we can be sure that our applications will scale automatically to meet the current workload. And scalability is basically a term used to describe a system's ability to cope with increased demand. So we answer questions like, what happens when we move from 1,000 concurrent users or 1,000 users to 100,000 users, or 1 million users to 100 million users? Our system will probably have to deal with an increased number of concurrent requests, as well as processing a lot more data. And for that, we have to provision dynamically resources. So we have to make sure that we add more resources or we reduce the number of resources depending on the actual workload. And with serverless, we dynamically add and remove those resources based on the number of incoming requests. The goal for this is to make sure that we maintain a reliable performance even when our load parameters are changing. Scalability is definitely a hard problem to solve. And by outsourcing the job of spinning up new instances and monitoring them, by outsourcing that to someone else, to the cloud provider or generally the serverless provider, we actually make sure that we have enough time to focus on how our components communicate with each other and how they scale together as a system as opposed to individually. And finally, probably one of the most important aspects of serverless that I've mentioned before is the fact that we only pay for what we use. So for 1 million invocations, using up to 128 megabytes of memory, and running for less than a second, we end up paying $0. You heard that correctly. So nowadays, basically, we can have someone buy all the hardware for us, set up all the load balancing, and install operating system, patch things for us, run code 1 million times, and we pay absolutely nothing for it. This is a wonderful time to build applications. And I encourage all of you, if you have a startup idea, if you have any idea, do make sure to try it out with serverless. You're gonna get very far. If we increase the number of requests or invocations from 1 million to 5 millions, then we're gonna pay less than $5. That's like less than the cost of a Starbucks coffee. All right, so we've seen some of the benefits of using serverless. And probably now everyone's really excited. I'm going to go home and try the serverless thing. But where do you get started? And there's two different components that make up serverless. So the first one is backend as a service, and that's third-party APIs that we might be using. Things like, for example, an authentication provider, as opposed to us reinventing the wheel and implementing authentication. Who here loves implementing authentication? We have Sarah, but I bet she's lying, right? Yeah. It's so much better to reuse someone else's service. And that's what backend as a service allows us to do. Reuse someone else's services, and they scale depending on demand. We don't have to worry about any of that. And then the other component of serverless is functions as a service. That is basically running code in ephemeral containers on demand. So these two components will make up your serverless architectures and your serverless applications. And you might actually already be using some of these services. So if you're using things like AWS DynamoDB or Azure Cosmos DB or any storage, any form of storage, like S3 or Azure Storage, you're already using managed services. And fully managed and highly scalable services are core tenets of serverless systems. They clear the path for us to focus on features that are truly relevant to our products by removing the need for us to learn how they work, how to install them, how to configure them, how to provision them. We only have to learn how to use their APIs. That's it. That's a good deal. And at the core of serverless applications, we also have functions as a service or cloud functions. And they run in ephemeral containers, as I mentioned earlier. in reaction to an event. So think of an HTTP request being sent to an endpoint. We can run code in reaction to that. Or a file being uploaded in a storage account, we can run code in reaction to that to process that file. Or even a very common task with serverless functions is running cron jobs. So you normally have to provision a server in order to run those cron jobs. But you can actually use serverless, and you don't have to set up any of the server configuration. And because our code is running in ephemeral containers, and for us to be able to scale out infinitely that code, you have to write stateless code. That might be a pain sometime. Your serverless function is like a goldfish. It has a very short memory. You cannot rely for state to be stored in between function runs. If you need that, you're going to have to save that state somewhere in a queue, for example, or a database. So you have to move that state outside your memory. Our code is also event-driven, so it reacts to specific triggers, which can be either triggered by your managed services or some of the other custom sources that you might define. And in a nutshell, this would be the processing model of a serverless environment, where you have on your left-hand side, you have your event sources, which can be a change that happened in a GitHub repository or a change that happened in a database. And that is being intercepted by a scale controller. And the scale controller is in charge of creating the function instances. So it will use basically some heuristics where, depending, for example, if you're using a queue trigger, if you're listening to events of messages on a queue, it will figure out how many instances it needs to create by looking at the number of messages that you have on the queue and the age of the oldest message on that queue. And based on that, it will create either 2 instances of functions or 100. And then the yellow things there are your actual code that's being deployed in a container. And then at the bottom, we can see some of the managed services that you might interact with from your serverless code. It's quite simple, right? 3 components. But with every new technology, we need to figure out what kind of tools are available for us and how can we add them to our tool set. And with serverless, we have a couple of options to consider. So we could use the browser for creating serverless functions. All you need is a computer and the browser running, and that's a good place to start with functions. This is a screenshot of my portal, which is in Azure. I work for Microsoft, so the examples here will be on Azure. But you can see here on your left-hand side, you can create new functions. And then at the center of the screen, you're going to see all the code that you've written. At the bottom, you're going to see the logs for your invocations. And on the right-hand side, you can actually test your code right there. So you can set your HTTP method, you can send parameters, and you can see the output of that invocation. You will see a very similar kind of screen for most of the other cloud providers with serverless functions. But as you get more accustomed and you get more excited about serverless, you're probably going to want to move from coding in the browser. You might want to move in your local. And as you do that, you're going to want to be able to write code in your editor of choice. You're also going to want to have tools that do all the heavy lifting for you and generate all the boilerplate code that you might need so that you can be super productive. You also want to be able to run and debug code locally. We all like that, right? And support for quickly deploying your code. What use does a code have if it's sitting only on our machine? It works on my machine, but nobody else's. So with the Azure functions, you're going to have support for that using the core tools, which you can install from npm. And then you can initialize a project using the CLI. So if you like using a CLI, you can use the func CLI. And it will help you do all of those things that we listed there. Otherwise, if your editor of choice happens to be VS Code, there's a wonderful extension for that. The Azure Functions extension in VS Code is probably the best thing that has happened to serverless, in my opinion. Once you have that installed, you can access the extension from the panel there, and it will allow us to create a new project, which is called a function app. And this is where you would group all of your functions together so that they can scale at the same time and you can deploy them together. It will also enable you to configure some custom settings for the entire project. So things like, what kind of runtime do you want to use? 2.0 is the latest version of the Azure Functions runtime. It will also allow you to customize the function timeout. So by default, it's 5 minutes. You can get up to 15 minutes with running serverless code. And then you can also configure some of the extensions that we have available. So think of the HTTP events. We can configure things like the route prefix, so add to our URL a certain part, like in this case tacos, or the number of concurrent requests that we want to support. Another thing that we want to do, since we're communicating with managed services, we'll also want to be able to use connection strings. That's part of our daily job, right? Be able to connect to data sources. And we're going to be able to do that using local.settings.json or application settings. We can configure them here. And then the next thing so we've created the project, we've configured global settings, then we're going to want to be able to create new functions. And here you can see some of the types of events that we can listen to, the languages that are available for us, and then this is the code that's generated for us, the boilerplate code, based on templates that we have already created for you. So this is an HTTP triggered function where we have 2 parameters there, the context object and the request data. The context object allows us to communicate with the platform API. So because in the serverless environment, we're shared the same operating system or the same environment, we share it with other customers or with other users. You don't have access to the low-level APIs. You want to be able to communicate with the platform API. And we do that with context. And this is a hello world function. And then here we I already talked about the context and request, and then we use the context object to log information, and then here we can set the response. The other important thing about functions and serverless functions is that we have access to bindings. We can use bindings to communicate with those data sources. And they are used to read and write data to databases or even send emails if we wanted to. They basically enable developer simplicity, better performance, and security. The serverless platform will manage for us those database connections. It will reuse those connections between invocation calls. And in a distant future, maybe or close future, we're also going to be able to do things like prefetching or caching data that we've already retrieved. And by using these constructs, we avoid hard-coding access to these services. This is an example of how we would define a binding to a Cosmos DB database. So it's a JSON object where we define the name, the type, and the connection string. Okay, these are some examples. And then we mentioned that we wanted to debug our serverless code, and we can do that from the IDE itself. We can either click on the debug button or filter over start debugging, and this will happen very easily. You can add breakpoints, and when you run, that will stop, and then you can inspect all those variables, just like you would do with any other programming language or any other environment. Serverless is awesome. So we've written all this code in our local. Let's imagine we built a wonderful API, and then we want to be able to push it to the cloud. And VS Code will help you with that as well. You're going to be able to right-click on your code or on your function in your IDE and say, deploy this to the cloud. But actually, there will be a warning there asking, do you want to override your existing deployment? And the answer for that should always be no, unless you're very sure that you want to do that. Ideally, you'll want to be able to either connect your serverless code to a GitHub repository, or even better, you're going to want to set up a CI/CD pipeline. You'll want to make sure that when you push code to your repository, you're going to build that code, and then you're going to install dependencies and run tests, and only after that push to production, right? We don't want to override our colleagues' code. This is an example of a YAML configuration that you can use to set up a CI/CD pipeline using Azure Functions, but you can use GitHub Actions for that as well, or Circle CI, whichever you want. It's quite easy to do. You have to use the exact same practices that you would use in your normal development environment. So hopefully you're kind of interested, you're asking yourself questions right now. When do I use serverless? Is this the type of thing that you can use for everything in your development environment, or are there any specific types of applications? And generally, you'll want to use serverless when building web APIs. So think of an example of an application where you can take a picture with your phone, and then that picture will get uploaded in a storage account, and we will resize that picture to generate thumbnails, and that will be available for our users. That's the hello world of serverless applications, and that's an API that we can easily use. Another type of application that you can implement is data processing. So think when you upload a CSV file in a storage account, you want to be able to parse that CSV, clean the data, and then save that data in a database or something. That's a serverless type of task. How many times do we build single-page applications, very fat ones, and then we have to connect to a third-party API, and in order to do that, we need an authentication token. What do you do then? You have to spin up a server and make the request from that backend. But as opposed to doing that, you can easily build a serverless function that will be like a thin layer between your single-page app and your third-party API. And Sarah has a very good example of how to build that with Azure Functions, how to call the Stripe API. She built a wonderful e-commerce website. And we've seen Charlie's talk about machine learning. Serverless is not quite there when it comes to machine learning. You cannot use serverless to train models, but you can use serverless to deploy your models. And you can also use serverless to build chatbots. An example that I built was a Slack command that I can add a query string, and then it will go to the noun API where I can retrieve icons, and then reply back in Slack, sending URLs to those images. I have the code on GitHub. I'll share that with you later on. But chatbots are a good example for that. And in practice, anything that's highly parallelizable, concurrent, asynchronous, or has spiky traffic is a good example for serverless. You want to spend the minimal amount of time solving the exact problem you need to address. And serverless helps you with that. Obviously, it's not perfect. And you have to, there's tons of recommendations out there. I think one of the issues with serverless is that it's not yet a mature technology. So there's different opinions and there's different ways of building applications using serverless. But I'm going to mention two recommendations that you'll want to use in your environment. The first thing that you need to keep in mind or remember is the single responsibility principle that states that every module, class, or function should have responsibility over a single part of the functionality provided by the software. And that responsibility should be entirely encapsulated by the function. The same is extremely important with serverless functions. When you deploy a function, you want it to have a single responsibility because it will deploy together at the same time. So it will influence your deployment strategy, and it will also scale at the same time. So you want to make sure that you group similar functionality together so that it scales similarly. The other important thing is to have a very clear understanding of how your system scales and which are your bottlenecks. One of the very first things that everyone that tries serverless encounters is they build this system that scale, or functions that scale automatically, infinitely. They have like 500 requests per second. But once they hit the database, if they use a SQL database, or if they use an on-prem type of solution, then that's going to be your bottleneck. And your system will just be as overloaded as it was before. And your users are going to be just as unhappy as they were before. So it's really important to understand, to have an overview of your application and understand which are your bottlenecks. Serverless enables you to solve problems creatively and at the fraction of the cost that we usually pay for using traditional applications. And our serverless applications will truly scale with our organization by enabling us to onboard users as our application becomes more and more popular. And I have nothing but gratitude and hopeful feelings about how your companies and your products are going to change the world. Based on my experience with serverless, I know that this technology is going to help you achieve those goals. So I'm super excited that it is here for you to build a better world. Thank you so much.